Hello and welcome to the next segment of Introduction to Autonomous Systems. If you recall, in the last session, we started our discussion on the various enablers of AI or the various disciplines of artificial intelligence, and we had looked at mathematics, philosophy, economics, neuroscience. In this segment, we will take the remaining disciplines or the main disciplines which contribute to the development of AI systems. So, let us begin this session. Let us take now the idea of psychology and its role in artificial intelligence system development. So, if we just do a little bit of background, the science of philosophy or psychology rather is believed to have started around 1820 through the efforts of Helmholtz and Wundt, who applied scientific methods to study human vision. And the main question that the psychology is trying to answer is how do humans, and they have also included animals in this whole process, think and act. So, the fundamental idea of thinking and action. You can realize that this is something which is going to be essential to creating a machine which can think and act. Initially, when the psychology discipline was evolved, it was restricted to behaviorism, and whose idea essentially was to provide objective measures of percepts or stimuli and its resulting actions, the response. So, its main focus was kind of an input output behavior, that if an input is given, what is the resulting response. This is how this whole thing was driven. It was also found that while this behaviorism approach worked well in animals, that you give them an input, it produced an output. In case of humans, it did not work as well as it worked in animals, which obviously meant that this particular way of kind of assessing the whole response or the thought action connection was probably not workable. And this also led to the development of another branch of psychology called cognitive psychology, which viewed the brain as an information processing device in which perception involved a form of unconscious logical inference. So, it was not just a pure input output device that you give a percept, a response comes. No. There was now recognition of the fact that there is something which is happening at the background which is equivalent of a logical inference. So, an inference is being drawn before an action is being taken, and this concept led to the establishment of legitimacy of terms, beliefs and goals, which were considered to be as scientific as pressure and temperature in the context of gases, which means they had the same quantitative personality that the physical quantities from other scientific disciplines had, and they also logically fed into the definition of a knowledge based agent who carried a small scale model of external reality and of its own possible actions within its head. And this is something which became different from the behaviorism, which was the initial focus and thrust of psychology. And this concept, that is knowledge based agent concept, required translation of stimulus into internal representation, manipulation of representation by cognitive processes and retranslation back to action, which means it was not just stimulus to action, it was a multiple level of internal representation, processing and transformation to action. So, it was a lot more complex phenomenon which needed to be understood. And this led to an important scientific field called cognitive science under the overall umbrella of psychology. And this evolved from a workshop at MIT in 1956, which brought out works related to use of computer models to address memory, language and logical thinking, because these were the tools that were used. For example, language was used to represent the stimulus or the translate the stimulus, and memory as containing knowledge, and the processing using the cognitive process which was logical thinking. Ultimately, you came to a decision or a conclusion that led to an action. Now, we come to the another important contributor to AI, or probably let us say main contributor, that all the theories, all the processes, all the algorithms that we have seen, or which are let us say contributing to the development of AI, will not come to anything if you do not have an artifact on which they can be implemented. And the computer became that artifact of choice for implementing the intelligence, autonomy and all the algorithms that are necessary to create artificial intelligence. So, the question which the computer engineering is trying to answer is, how can we build an efficient computer? And this has been the question right from the inception of the whole field when the computer started in 1943, when a machine was constructed for the sole purpose of deciphering German messages during World War II. So, this was the first instance of a computer being created more than 80 years back, whose only purpose was to decipher German messages during World War II. Ever since, the advancement in this field have been at an astonishing pace, with doubling of performance every 18 months till about 2005, when parallel processing took over, and then we started having parallel computers, 4 node machine, 8 node machine, 64 node machine, 128 node machine, 256 node machines, and then the whole thing keeps going. Current expectations are that future increases in computing power would come only from massive amount of parallelism, and this has already been established as a feature of the human brain, that human brain does lot of parallel processing, that there are multiple processes running inside the brain and they are being activated by different inputs, different outputs. So, it has been recognized that more and more computing power will come only through parallel processing. Of course, apart from advances in hardware, AI also is significantly supported by the development in the software, which means languages specifically suited for AI related applications and operating systems for managing the AI related tasks. Now, next we come to role of cybernetics and control in artificial intelligence. The early evidence of control applications has been traced to a water clock with a regulator to maintain the flow rate, which was developed in 250 BCE or before Common Era. And the fundamental question that cybernetics or control is attempting to answer is, how can artifacts operate under their own control? That is the question which the discipline is trying to answer. Norbert Wiener is thought to be the pioneer of control discipline when he, along with some colleagues, proposed that behavior resulted from a regulatory mechanism to reduce error. This became the fundamental thought of any control or cybernetic system, that there is a regulatory mechanism which reduces the error, and the behavior of a system is a result of this regulatory mechanism. And in fact, Weiner was the one who wrote a book on cybernetics, which of course became a bestseller and gave rise to the possibilities that intelligent machines could be created. Another book called The Design for a Brain propagated the idea that intelligence could be created by use of appropriate feedback loops for stable adaptive behavior. So, which means there was this particular facet of control theory which also came into this concept of AI and autonomy, that appropriate feedback loops for a stable adaptive behavior could essentially create the intelligence that people were looking for in machines. Of course, in recent times, concepts of stochastic optimal control have matched with the objective of artificial intelligence, as these aim to maximize an objective function over a period of time under uncertainty. So, what stochastic optimal control does is exactly what is the objective of an AI system, that it is trying to get a best possible outcome under uncertainty. The role of linguistics. In 1957, Skinner published a paper titled Verbal Behavior, which was a comprehensive and detailed account of behaviorist approach to language learning, as to how a person learns a language. And over a period of time, even today, the linguists are trying to answer the question, how does language relate to thought? Which means, what is the connection between thought and the language? I am sure many of us have realized that many times when we are thinking, we use a language in mind. We do not speak it explicitly, but the thought essentially is in a specific language which we may be comfortable with. So, there is a relation between the thought and the language, but we need to find that. At some point, the behaviorist theory of language was replaced with another approach called syntactic structures, which was based on the observation that a child could form sentences which it had never heard, which essentially it meant that it was not really the verbal behavior exactly, but there was syntactic structures which the child could capture and then form sentences which actually were never in its memory. It could form new sentences. So, how does linguistic enable AI? Of course, this syntactic structures theory not only explained many other aspects, but more importantly, it was amenable for programming, which was an essential requirement for creating AI systems. Of course, we now have many other tools apart from syntactic structures, such as computational linguistics and natural language processing, along with the realization that apart from language, we also need knowledge of the subject matter about which a thought is to be created. Current generative AI solutions, or what we popularly call chatbots, have used this aspect through the development of LLMs, the large language models, and the SLMs, the small language models, for text and image processing that is very near to human intelligence. So, all current solutions have made use of syntactic structures, computational linguistics, natural language processing, along with bringing in the subject matter knowledge as part of these LLMs, so that they can now give you answers which are almost close to what a human being would give if a similar question was asked. So, to conclude this part, almost all fields from science and engineering to humanities have their role in creating autonomous systems that are expected to work in human and nature centric context. With that, we come to the end of this segment, and in the next segment we will look at the overall status of the artificial intelligence domain and its various possibilities in future. So, with that we come to the end. So, bye for now and see you in the next session. Thank you.